So we have learned the definition of the derivative, which is given by f prime of x equals the limit h approaches 0 of fx plus h minus f of x divided by h, and take the limit, right? So sometimes you will see a very similar formula. We replace h with delta x, so the delta x always represent the change in x, right? So it becomes f of x plus delta x minus f of x divided by delta x. So they are the same thing, except here is h, here is delta x. So delta x is not triangle times x, which is a single symbol which represent the change in x, right? H is the change in x, right? From x to x plus h. So this is the change, h is the change in x. So here, sometimes we will use delta x to represent the change in x. So they are the same thing, right? So you will see that from the examples in the previous lecture, when we try to find the derivative, so we needed to do a lot of things, right, to evaluate this limit. It's not hard, but sometimes it's not easy. Some problems are not hard, but some problems would be very complicated when you do the calculation for this limit. So some students may ask if we have any rules we can follow to find the derivative quickly. Yes, we have some rules which are called basic rules. We can use these basic rules to find the derivative for most given functions. Okay, so now let's look at the first rule, which is called the constant rule. The constant rule says if function f of x equals c equals a constant function, which is a horizontal line, right? So the derivative of this constant, which is what? We use a different symbol, c prime, which would be 0. Okay, so this is called constant rule. Why? We can use this formula to identify this result. So we know that f prime of x is equal to the limit delta x approaches 0, which is f of x plus delta x minus f of x divided by delta x. So here I use delta x instead of h to help you to be familiar with the different notations. So the limit a delta x approaches 0. What is f of x plus delta x? So f of x is, no matter what values of x, it always be c. So this one is also c. c minus f of x equals c. So c minus c divided by delta x. So the denominator would be 0. So at last, this fraction is 0, right? You cannot plug in delta x equals 0. Otherwise, you will have 0 over 0 form. But you simplify this fraction, so you will have 0. So we know the limit of a constant equals 0. So it's equal to 0. So from the graph, we know this is a horizontal line, right? The horizontal line at any point always have the slope, which is the tangent line coincide with the horizontal line, right? So any slope, the slope at any point, which is 0, because the horizontal line has the slope 0, right? So this one, the derivative of a constant equals 0. So a quick example is the derivative of constant 3, right, which is 0. The second rule is a very important rule, which is called the power rule. So we assume n is arbitrary rational numbers. And then we want to know what is the derivative of x to the n. So this one can be written as x to the n, then take the prime. The same thing, okay, just different notation, which is equal to what? Equal to, you bring down this n in front of x, then the new power would be n minus 1. Okay, so this is the, so you can also to prove this result using the definition of the derivative, it costs time, so we skip the proof. So now let's look at the examples. Bring down 1 times x to the This power rule, let's look at another example, would be very powerful. For example, let's look at this problem. We want to find the tangent line of the function f of x equals x to the fourth at the point when x equals -1. So the first thing is what is the point when x equals -1? So f of -1 would be f of, let's evaluate this point at -1. So this one is -1 to the fourth, right? We replace x with -1, so it's 1. So this point, the point is -1 point, right? So we want to find the tangent line through the -1 point for this function x to the fourth. So now you don't need to use the definition, the limit process, to find the derivative at any point. Then you plug in -1. No, you don't need to do that because we know the formulas we have, right? We have the basic rules, which is called the power rule. F prime of x, this is the derivative at any point, right? Of this function, which is actually x to the fourth, take the derivative. So this would be, we bring down 4, then subtract 1 on the power to get a new power. So it would be 4x cubed. So this, remember, you cannot use this one as the slope because this is the slope at any value x. In other words, this is the slope for the tangent line at any point. We care about the tangent line at this point, so that means we need to find the slope at this point. This point has the x value, which is -1, so we need to find this one. So this would be x to the 4 times x cubed, then evaluate at x equals -1. We need to find this derivative, then plug in -1. So this would be 4 times -1 to the cube, which is -4. So this is the slope of the tangent line at this point, right? So now, what is the equation of the tangent line? So we have the slope, we have the point, we can use the slope point form. So this is the y minus the y coordinate of this point times the slope f prime at this point equals the slope times x minus the x coordinate of this point. So if you plug in everything, so this would be -4 times x plus 1. So this is the point slope form. If you want to continue to simplify, depends on the problem, right? If the problem asks you to do that, you need to do that. You expand, right, plus 1 on both sides, right? So y is equal to -4x minus 3. So this is the equation for this problem. Both answers are acceptable.